Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss about the surface tension of on liquid droplets. In the previous lecture, we have discussed regarding the theory part of surface tension. In that, we have also discussed regarding the coercive force and adhesive force in the liquid. Now we'll see the surface tension on liquid droplets. Let's consider a small droplets of liquid, okay, and a small radius of r in this liquid droplets, and in this total entire surface, if you consider of the droplet, the tensile force due to the surface tension will act on this. Now in this droplet, okay, let cut the entire surface into two halves. Okay, let cut the surface into in these two halves. So this is one half will be there. Okay, after cutting, let me show you. After cutting, it will be so like, and this will be one part. This is one part, and another part will be also similar kind of things will be there. Let me show you this. Yeah, this is the two different part is there. Okay, this is one half, this is another half. Now in this, if you see, the surface tension is acting on this surface of this liquid droplets. This is the circumference of this. Yeah, so these are the forces what we can see at this surface tension is acting on that. Okay, this is at one circumference of these droplets after cutting this total droplets into two halves. Okay, another one is there, that is the pressure force will be there. This is surface tensile force which is acting on this, and another one will be the pressure force. Pressure force which is acting towards the droplets. So for this, if you see, we can identify that what is the pressure acting towards the liquid droplets after detecting. Okay, and this pressure actually the pressure intensity which is present inside the droplet. The pressure intensity which is present inside the droplets. Okay, so to calculate the surface tension of the liquid, or to identify that one, we need to consider this. One is surface tensile force, another one is pressure force which is acting on that. So for that, we'll first identify, first we'll calculate the tensile force, which is acting on the due to the surface tension which is acting in the surroundings, in this circumference, you can say, of that portion. So how to calculate this tensile force this one? So that actually the surface tension which is acting on this total circumference into pi d, that is the circumference of that. Okay, so pi into d, this is the tensile force. Another one is, as I told you, second one is, that is our pressure force. That is the pressure force which is acting in the liquid droplets. Pressure force which is acting on this. So that will be equal to, P into the area, that total area here. The force actually, pressure force equal to the pressure which is applied on this total area. So area of these liquid droplets, we can say this is a circular one. So that can be considered equal to P into pi by 4 into d square. Pi by 4 into d square. Now these two forces should be opposite, like equilibrium condition. So to make it equilibrium condition, or we know that these two forces will be equal and opposite. So what we'll do, let's compare these two equation. So what will there, sigma into pi d equal to P into pi by 4 into d square. So what we'll get here, let's keep one side the pressure intensity equal to Now here pi d will be cancelled and this side d will be there. Now p equal to what we can get, 4 will come this side. So 4 sigma by d. So this is the pressure intensity for the surface tension on the liquid droplets, 4 sigma by d. That means if the diameter droplet diameter decreasing, then we can say the pressure intensity of the droplet is increasing in that way. So we can write the diameter d decreasing means the pressure intensity inside the droplet increasing. Okay, so this is the summary of this surface tension on liquid droplets. Okay, similarly, let's see another one condition, surface tension on a liquid jet, and we'll see surface tension on a hollow bubble. So surface tension on a liquid jet, actually similar type will be there, only the shape will be different, that's it. So here if I'll consider a liquid jet, let me draw like this. So liquid jet will be like this. So here also will be actually cylindrical type will be there. So let's consider a small liquid jet in which the length of the jet L, or you can say this is the height is there, capital L, and diameter of that liquid jet is small d. We can consider this one. Okay, now this is the length and d. Now we need to find out what is the surface tension on the liquid droplets, liquid jets, and the previous one droplet and this one jet. Now again same thing, if I'll take half of this portion of this, okay, and the half portion, how it will be, like, you know, if I cut this one, then we'll get like this, you know, this portion and this one, join it, and this will be the side width one. Okay, now here also similar kind of things will be there, the pressure intensity inside the liquid jet, okay, and another one is surface tension of the liquid. So here also we can mark all this surface tension at the circumference is there and the pressure which is acting in the liquid jet. Okay, so this is sigma, because if you detach both the liquid jet, then we can see inside one pressure will be there which is different from the atmospheric pressure. Okay, so this is the sigma is there. Now here also again two things will be there, one is pressure force, another one is surface tensile force will be there. So we can identify this pressure force and surface tensile force. So first one we can write the force due to pressure in the liquid jets equal to, we can write P into area of the you can say half portion or semi jet, we can say this is full jet and this was this is, we can take semi jet. So area of semi jet, so that is nothing but we can write P into here we can write L into diameter d, length into diameter d, so PLD. This is the force due to the pressure. Now similarly we can write the surface tensile force, the force due to the surface tension, that one we can write the force due to surface tension, we can write that is sigma into, we can write 2L, we can write 2L because these two sides are there, and here if you consider this is one length L, another side one length L, so 2L we can write. This is the surface tension, force due to the surface tension, or tensile force you can write this one. So that is nothing but sigma into 2L. So now this is one equation and this is one equation. Again, if you equate these two equation 1 and this is equation 2, let equate these two equation 1 and 2, we can write PLD equal to sigma 2L. So that implies, so L can be cancelled, and we can write P equal to, here it is 2 sigma by D. So this is the pressure intensity and sigma and diameter correlation in the surface tension on the liquid jet. Okay, previously what we have seen, P equal to 4 sigma by D. This is for the liquid droplet case. Okay, single liquid droplet case, and this is for the surface tension on the liquid jet case. Okay, jet will be there, and now take the half portion of this semi jet, and we'll find out this force due to the pressure and the surface tensile force on this due to the surface tension of the circumference. Now another one is there, that is surface tension on a hollow bubble. So actually this is surface tension on a hollow bubble is nothing but it's like a soap bubble will be there. Okay, if you have observed this, like soap bubble will be there, which is having two surfaces will be there. Okay, two surfaces will be there, like a soap bubble. It has two surfaces in contact with air, and these are the air contact will be there. That means what it meant to say, it is having two different two surface contact. One is contact with the one is inside, another one is outside will be there. Okay, one inside, another one outside will be there. Okay, so for this you can get two surface contact will be there. So for that again we need to find out the pressure at this surface tension due to the tensile force due to the surface tension. Another one is pressure force. Okay, so now for that we can write what is the surface tensile force, that we can write tensile force due to the surface tension, tensile force due to the surface tension equal to, we can write, we know that what the circumference is there, that is pi d, and surface tension, that is pi. So pi into sigma into pi d. This is for one surface, but here we will have two surfaces. We'll have two surfaces. Okay, so for this we can write pi into d into 2. So that is nothing but 2 sigma pi d. And another one is, as I told you, the pressure force. The pressure force, the force due to the pressure, you can say pressure intensity, that will be as usual the pressure applied and the total area. So area will be, again here we can consider one circle, so that will be here pi by 4 d square. And now this is, as I told you, this is the pressure force is there, and this is the 2 sigma d, the tensile force. Now if you compare these two equation, you can get pi d we can cancel, so only d will be there. Now p equal to, you can write p equal to 4 will be taken this side, 4 sigma into 2. 4 sigma into 2 is there, so that will be 8 sigma. 8 sigma, and this d will be come down, that is d, denominator d. So this is another one formula, pressure intensity, surface tension and diameter. Okay, so these are the three correlations are there: surface tension on a droplet, and surface tension on a liquid jet, and surface tension on a hollow bubble. So three different concepts, so three different equations are there. With the help of this equation we can solve many problems, and which will be helpful for to identify to calculate small problems where the pressure intensity given and its sigma need to be calculated or diameter need to be calculated. So any one terms will be not given, that need to be identified. By using these correlations we can identify the answer. So I hope you understood regarding this concept. If you are having any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you all.